Welcome. This question says a coil of wire consists of 40 turns. The coil has an area of 5 square meters. A magnetic field is perpendicular to the plane of the coil, and the strength of the magnetic field passing through the coil changes at a uniform rate from 2 teslas to 10 teslas in 6 seconds. Everything else is unchanged. You're not changing the area, you're not changing the number of turns. And what is the magnitude of the EMF induced in the coil? So let's visualize. Here's my coil, and I have let's do a different color. I have a magnetic field, flux lines, but I can represent it as a B vector, a magnetic field going through. And what I can say is that my number of turns is equal to 40 windings, loops, turns, it's all the same thing. And then I have my area. This is the area of this opening in the coil. So my area equals 5 square meters, and then this is perpendicular, so we can show that like that. So it's perpendicular to the plane of the coil. The strength of the magnetic field passing through the coil changes from 2 to 10. So BI is equal to 2 Tesla, and BF is equal to 10 Tesla. And then my amount of time it took is equal to 6 seconds. And then what is the magnitude of the EMF? So I need a relationship here, and the relationship is Faraday's law. So E is equal to minus N d phi B by dt. And of course phi B we learned before is equal to, well, it's going to be the magnetic field strength multiplied by the area multiplied by the cosine of the angle between the two. Put another way, phi B is equal to B dot A, where we have a magnetic field vector and we have an area vector. For our purposes, we'll use the top equation. So we substitute in, and we say E is equal to minus N, and then we go d by dt of this equation, BA cosine phi. And clearly what it means is that, in order to change the flux through the coil, I can change my magnetic field strength, leaving the area constant and the angle constant, or I could change my area, leaving the magnetic field constant and the angle constant, or I could change the angle, leaving the field constant and the area constant, or I guess I could do all three. I could just mess with the thing completely. So, but today we're going to do just the magnetic field. So then, okay, let's take out all the things that I know are constant, and the B is going to be constant, and the A is going to be constant. Oh, I'm sorry, that's not true. Let's go off autopilot and start thinking. So the B is going to change, so the A is constant and the cosine of the angle is constant, but I have d by dt of B. That's going to be minus N A cosine the angle delta B over delta T, and I can expand this to equal minus N A cosine theta, and I'm going to have B final minus B initial over delta T. So let's put some numbers in. So my EMF is equal to minus N, well, that's 40, times A, and A is 5, and then cosine theta. It says that the magnetic field is perpendicular to the plane of the coil. So my magnetic field is in that direction, and the area vector is in that direction. If my magnetic field is perpendicular to the plane of the coil, then I can define an area vector which is perpendicular to the plane of the coil. That's what I do with area vectors. And so I see these two guys are actually parallel to each other. So that would be cosine of 0. And then I have BF. Well, I have BF, and BF of course was 10 minus BI, which is 2, all divided by 6 seconds. So this is going to be minus 40 times 5. Cosine of 0 is 1 times 8 over 6. So my EMF is equal to minus, let's have a look, 5 8s are 40, 40 times 40 is 1600 over 6, so that would be minus 6 goes into 16 2 times, carry 4, 6 6s are 36, carry 4, 6 6s are 36.6 volts, so that's minus 266.6 volts. So the magnitude, because it's asking for the magnitude, is just, it's just that numerical value, 266.6 volts. So the negative sign is there to tell us which way the EMF points. Remember, this change is inducing a current in the coil, and we can visualize that as being caused by an induced EMF. But the question is, did the current go around clockwise or counterclockwise? And so we need to have a sign for our EMF, and so that's what that negative sign is for. Okay, so there we have it. Rather than changing the flux, I changed something that causes the flux. So in this case, I changed my magnetic field over time. I kept area constant, I kept the angle constant. But as we'll see, we can play with those other two parameters as well. So there we have it.